So one of the things you're going to have to do in order to find the equation of a circle in standard form is practice completing the square. So let's do that here with these two examples. So you've got this equation, x squared plus 6x equals 5. If you wanted to make the left-hand side a perfect square trinomial, that is the square of some binomial, then there's a little process that you're going to have to follow to figure out what number to put right here would make that a perfect square trinomial. So what number to put where I have in yellow? And the trick is to take half of the middle coefficient. Half of 6 is 3. That's the first step. The second step is to square that number. 3 squared is 9. So 9 is what you would add to both sides and get x squared plus 6x plus 9 equals 5 plus 9. So 5 plus 9 would be 14. On the left-hand side, though, you could now rewrite this because this is x plus 3 quantity squared. And that's what we'll be looking for as we work on these things, is to rewrite it as the square of some binomial. Now let's practice that again right here. So we got y squared minus 8y plus something equals 3 plus something. So what I want to do is I want to figure out what is it that I have to put right here to make this a perfect square trinomial. So what number am I going to add there so that this is the square of some binomial? Ah, well done. Thank you. So half of negative 8 is negative 4. Actually, this should be part A. And then second step is to square negative 4 and get 16. And that was a little bit zoomed out, my bad. Perfect. So if I put a 16 here and a 16 here, then this becomes something squared equals 19. What do I square to get x squared?
Y minus 4.
There we go. Y minus 4. Perfect. Perfect. So it's that idea of completing the square that you're going to need in working with stuff like this one down here. Write this equation in standard form. So let me just grab myself a little real estate here on this one and go ahead and show you how that works. Now, one thing that's kind of a little foreshadow here, I can tell this is going to be a circle because the coefficients of the squared terms are both the same. There's a 1 here and a 1 here. And when that happens, your conic section is going to tend to turn out to be a circle. At least it will in this class. Okay, let's bring the x's together. That's going to be x squared plus 8x. And then y squared minus 6y. And that's going to equal negative 24. What I want to do is I want to complete the square on both of these. So I'll write this as x squared plus 8x plus something plus y squared minus 6y plus, again, something equals negative 24. And then we're going to have to add a couple things to that when we figure out how to complete the square here. So let's take stock of what we got here. To complete the square on this one, I'm going to take 1/2 of 8 and get 4. And then 4 squared gives me 16. Okay, perfect. If you're watching this at some other time, try and pause the video and take a look and figure out what I put here before I actually write it. So 1/2 of negative 6 is negative 3. Negative 3 squared is 9. Now I can't just add 16 and add 9 to the left-hand side without doing something similar to the right-hand side. So let's do that. I'll add 16 and I'll add 9 to the right-hand side. That way it keeps things in balance. This is now a perfect square trinomial. What do I square to get the first one? Thank you. X plus 4. And then anyone else?
Y minus 3.
Y minus 3. Thank you. Negative 24 plus 25 equals 1. So, cool. You can now determine things like the center and the radius. The center is going to be at negative 4, because negative 4 is what makes this square term equal 0. Negative 4 and positive 3. And the radius is the square root of 1. Please don't leave it like this. Square root of 1, I expect you to simplify as 1. Awesome. Awesome. How are we looking with this one right here? Doing okay there? Let's spend a little bit more time completing the square, and I'm going to put this one in standard form. So let me grab a fresh piece of real estate here. So we've got y equals negative x squared minus 2x plus 15. By the way, if I were to graph this, what shape would I see?
Parabola.
A parabola, because you only have one square term. Now let's take a look back at the last one. If we were to graph that one, let's see. Yeah, that was example C. So I can get rid of, say, the first one, get rid of that one, and click on example C. So there you go. Perfect. Notice that I've got a center at 4 and 3. Wait a minute. Did I make a mistake? Oh, you know what? That should be a plus there. There's a mistake in this. It should be a plus. That'll mess things up a little bit. Yeah. So I have to adjust the center there. The center is where we said it was, negative 4 and positive 3 and a radius of 1. So nice. This one is a parabola. Which way is it going to open? Left, right, up, or down? Let's get rid of that. Yeah, it's going to open down because of the negative. Now, there it is. Before I zoom in and figure out the vertex and stuff like that, we're going to play a game of complete the squares on this one as well. So I'm going to move the 15 to the other side and get y minus 15 equals negative x squared minus 2x. Now the thing about completing the square is that you can only do it when the coefficient of x squared is 1. So if there's anything else there, like a negative, you're going to have to factor that out. So if I factor that out of both of these, I end up with something like this. Now I'll play that game of complete the square. Half of 2 is 1. 1 squared is also 1. So I'm going to put a 1 there. But there's a little tiny tricky part here. Let's see. A little Photoshop here. Plus something equals negative x squared plus 2x plus something. Now I filled in that hole with a 1, but if I put a 1 here, what should I do to the left-hand side? And it's not put a 1.
Negative 1.
Negative 1, because that 1 here gets multiplied by a negative, so I really subtracted 1 from the right-hand side, so I have to subtract 1 or add negative 1 to the left-hand side. Well done. So this becomes y minus 16 equals negative x plus 1 squared. If I move that to the right-hand side, your work with parabolas up to date should really help you out here. This is in the nice standard form that I wanted. So let's see if we can't figure out the vertex. Vertex would be where? Well, what value of x would make the squared term equal to 0? You don't have to look at that, just look inside the parentheses. What makes this 0? X equal to -1. And if I put in a -1 here, this whole thing would be 0. What would I get for y?
16.
16, perfect. So that should be the vertex. Let's take a look back at Desmos and see if we got it right. So I'll kind of zoom out a little bit and then scroll down. So here we go. Bam. -1 and 16. Cool. Now, essentially what you've got two different forms for this graph. All right, you've got this one right here, and equivalently, this one down here. They're both the same. They're just two different ways to write it. So one can be more convenient than the others. In fact, for instance, if I had to find my y-intercept, so the y-intercept, you'd set x equal to 0. And that's going to be your y-intercept, where the graph crosses the y-axis. Is it going to be easier in the first equation or the second equation to set y equals 0? I kind of like the first equation, because if you put x equals 0, that's gone, that's gone. You're just left with 15, right? So 0, 15, that'd be another point. But as far as finding the vertex, can't beat the second equation. If you set x equal to 0, if you set y equals 0, then you can find the x-intercepts. So there's your y-intercept as predicted. And then you got some x-intercepts as well. If you set y equals 0, you can find those. So I would probably again do that up here. 0 equals -x squared minus 2x plus 15. You don't necessarily have to trot out the quadratic formula to solve this. If you just multiply both sides by -1, you can factor this and solve. So x would equal -5 and x would equal 3. Exactly what we saw when we graphed this on Desmos. So it's a nice way to double check yourself. But I'm throwing that in by way of review, because at some point soon you're going to have a final exam on this stuff. Okay, let me shut off some of these, and we'll go down to one or two last ones. One of the ones you'll see in the homework is kind of short and simple. I don't even have it on my sheet here, but let me just look at it with you. Something to the effect of x equals 2y squared, or x equals 3y squared. Kind of looks nice and simple, right? But it's made a significant change to our graph. Can anyone forecast what change that would make if I graphed x equals 2y squared as opposed to y equals 2x squared? Well, let's just put it up here. X equals 2y squared. What's different about this graph than our usual graphs of a parabola?
It opens up right.
Yeah, it opens sideways. All right? Doesn't open upright. You're correct. So, that's interesting. Now, when you graph this on WebAssign, they're going to want you to start by graphing the vertex, and you're going to need to graph one more point. So let me help you find that one more point. And you can find that one point, in this case, by plugging in a value for y to get the value for x. So I already know, for instance, that if y is 0, so is x. But let's plug in y as 1. If y equals 1, what does x equal? 2 times 1 squared. Going once, going twice. 2. There you go. So 2 and 1. By the way, it wouldn't matter if you plug it in a 1 or a negative 1. 2 times negative 1 squared, still going to be 1 times 2 is 2. So both of those are actually there. You might notice that this fails the vertical line test, but it does pass through the point 2 and 1. And 2 and negative 1. So, okay, with that, let's see if we can't determine the vertices for these last two. And it's just a matter of saying to yourself, all right, well, what makes the squared term equal to 0? So let's take a look at this one. What's going to make the squared term equal to 0?
Negative 1.
Negative 1. Now we got to be careful about something here. What variable becomes negative 1? What are we going to set equal to negative 1? The y coordinate, right? And if I set y equal to negative 1, I end up with negative 1 plus 1 is 0. Squared is still 0 times 2 is 0. What do I get for x? When I set y equal to negative 1, what do I get for x? 3, right? Because this just disappears. So that's your vertex. Now you got to be a little bit careful about that because our temptation is always to write x then y. But in this case, it's y then x. So if you make a mistake, if you wrote negative 1, 3, that's the wrong spot. 3, negative 1, that's the right spot. That's the one that you want. So, cool. Last chance here, or last problem I should say. See if you can't figure out the vertex here. And if you're following me online, once you've got it, you can click this down here to do the big reveal, see if you got it right. But let's see if we can't figure out the vertex for x equals 3 times y minus 2 squared minus 1. Any takers? What's the vertex going to be? I'm hoping this is something you can just read off. Start with the squared term. What's going to make the squared term equal to 0?
2.
2. And if I put in a 2 here, what's left for x?
Negative 1.
Negative 1. Thank you, ladies. Let's see here. Let's cut back over to here and graph it, and bam. Well, negative 1, 2. Yeah, perfect. Exactly what we expected. Okay, that should do it. Comments or questions on this section? At least the bonus material stuff? All right, go get them.